Okay, so our last transformation is going to be when we have multiplication inside the trig function, meaning the theta or the x, whichever you have, is being multiplied by a number. In a normal case, that's called a horizontal stretch or compression. We're going to get more specific here, and this is going to be called a period change, because horizontally it's going to affect how often these graphs repeat. So in order to figure out how to use it, we need to take into consideration the normal period of these graphs, meaning when we graphed it before we changed it, is 360 degrees. In order to find the new period of a graph, what we need to do is this 4 is going to be affected with the 360. You take 360 degrees, divide by whatever number is in front of that theta. So in this case, we're going to do 360 divided by 4. The new period of this graph, that means, is 90 degrees. So what that means is it's going to repeat every 90 degrees. So it's going to repeat more often. For our graph, what that's going to change are the labels of the function. So in this case, we're still starting at 0 degrees. There's our start. Our end this time, to just graph one period, instead of going all the way to 360, our end is going to be 90 degrees. And now we have to divide that up into fourths. So to divide it up into fourths, a couple ways we can deal with it. I think if we just divide 90 in half, that gives us 45 degrees. And then if you divide 45 in half, that gives you 22.5 degrees. And then to get that third tick mark, you can essentially just add those together. So 22.5 plus 45 degrees gives us 67.5 degrees. Another option to figure out kind of what those tick marks move by. So for the new tick marks, we know we're dividing our period up into fourths for our graphs. So if you take that new period of 90 degrees, just divide it by 4, and that tells you every tick mark we're going to move at 22.5 degrees. So either way you want to work with it, but you need to make sure you have your labels for all those fourths. Now everything else on this graph is the same as always. Amplitude is 1. It's going to go up to 1, down to -1. This is a cosine graph, so cosine starts at the top, down to the middle, bottom, middle, top. Connect all your dots, and you're done. So the period is going to affect how often it repeats, which when you're graphing it, is going to affect what those labels of your graph are. So we'll do one more of these. In this case, again, the period's affected by whatever is being multiplied by theta. So now our new value that's going to affect that period is 1/2. So again, to find out the period, you have to take 360, because that's the normal period of the graph, divide it by whatever is before theta. So in this case, it's dividing by 1/2. Well, if you think about how fractions divide, that turns into 360 times 2, which means the new period of our graph is going to be 720 degrees. So we draw out our axes. There's no phase shift, so our start is still going to be at 0. Our end of our graph is going to be at 720 beyond that. So the end of our graph is 720 degrees. So now to figure out how to divide this up, two options. This time I'm just going to figure out the tick marks. So to figure out those fourths, just take 720, divide it by 4 again, and we get that the graph is going to change every 180. So that means the first tick mark will be 180. The second tick mark will be 180 times 2, which is 360. The third tick mark will be another 180 beyond that, which will be 540. And then add another 80 to that, and you should end up right where you started at 720. So now the last part's just to graph it. This one doesn't have any other shifts, so amplitude is still 1, up to 1, down to -1. This time it is a sine graph. So sine starts in the middle, then sine goes up to the top, back to the middle, bottom, middle. Connect all your dots, draw your arrows, and there's your graph. So again, make sure you are labeling those tick marks. That is imperative to show what the period of this graph is.